Hi everyone. Today we will be presenting our research on evaluating cutout rendering techniques for pass-through embodiment using a real mirror metaphor. In our work, we are investigating how we can make self-representation in mixed reality more believable by changing how we render the edges of the user's body. Avatars are essential for presence, as a stronger body perception leads to a more immersive experience. However, traditional realistic avatars currently require complex, time-consuming scanning processes. Previous work has shown that embodiment can be drastically improved via integrating the own body via using mixed reality video streams and cutting out the own body compared to traditional avatars. However, they often used external hardware or had the need of high-performance costs. That's why, we introduced in our previous work pass-through embodiment, in short PTE. Instead of requiring external hardware, PTE uses egocentric video pass-through and integrated depth sensors of modern XR devices to cut out the own body via depth segmentation. Unfortunately, these depth sensors are often low resolution, thereby creating visual artifacts. Current implementations force trade-offs. On one side, we have hard cutouts which are binary and sharp but suffer from jagged, unstable aliasing and temporal instability. On the other hand, we have soft cutouts, which create a gradient by multisampling and alpha blending the depth map. These eliminate visual stare artifacts, but internal testing revealed that it has a distracting factor and create a ghosting effect that lacks visual stereo anchoring. The hard edge was also used in our previous work. That raised the question, is there something in between? Indeed, we found a potential alternative as a middle ground, dithering. This is a technique from computer graphics that applies an ordered noise-based pattern to the edge by using a high-frequency Bayer matrix. Thereby, we assume that we create a gradient that potentially tricks the eye into seeing a smooth edge without the stereo disambiguity from alpha blending. We extended our previous pipeline, which already had a gradient, by multisampling the depth map and creating a soft edge. For the dithering, we wanted to have more control via the edge definition. That's why we modify the gradient value, as well as using a LUT to achieve an ordered squared dithering value to use for clipping. This also added negligible performance cost to the pipeline with less than 0.1%. In order to evaluate the impact of our new technique on PTE, we formulated the following research questions. How does cutout rendering in PTE influence presence, embodiment, and user acceptance in VR? To test this, we conducted a within-subject study with 30 participants with the Quest 3. Most of them were European, with a mix of genders. As dependent variables, we chose to have various established questionnaires for presence, self-presence, embodiment, VR sickness, and additional questions about perceived artifacts and user acceptance. We also took objective measures of movement, body look count, and duration. As an independent variable, we had the edge rendering type, with the soft, hard, and our dithered edge. We set up a physical room that matched the virtual living room environment. This alignment allowed for free movement within a defined safe walking area. A key novelty of our study was the real mirror. With a clever setup, this forced users to confront their own edges. We are the most familiar ones with our own selves, and providing, thereby, a real mirror reflection is the most critical self-assessment possible. As we want to achieve most comparable results, we ensured a fixed schedule with audio instructions. This involved an VR adaptation phase, followed by a task, and then a guided mirror embodiment phase. We repeated this block for all three rendering conditions. For the task, we chose to have common pick and place task where the participants sorted books. We chose this to induce natural, functional movement before asking them to critically examine their body in the mirror. We found multiple significant results across the measured scales. To account for our three conditions, we used Bonferroni-adjusted p-values within our omnibus tests to keep the analysis conservative. We found significant differences in the IPQ. The dithered condition consistently outperformed the hard condition in general presence, spatial presence, and involvement. For the self-presence, we found a global effect, but no effect in the pairwise comparison. For embodiment, dithering also scored significantly higher than hard cutouts in the control subscale. Interestingly, regarding artifacts and acceptance, we saw trends but no statistically significant pairwise differences. We also forced the participants to the rendering conditions. There, users preferred the soft cutout, followed by dithering. Hard cutouts were ranked lowest. This now finally means that the cutout rendering in PTE is influenced. Our dithered edge partially increases presence compared to hard edges, while edge rendering in general also influences self-presence. Regarding the embodiment, we have a similar tendency where the dithered edge improves agency compared to hard edges, while edge rendering in general influences change. Essentially, users felt more in control of their virtual body when the edges were dithered rather than sharp. As we found no physiological impacts, the ranking outcome introduces a mismatch, where soft is ranked highest and hard lowest. The subjective rankings therefore did not align with questionnaire scores, proposing a different thinking regarding preferences. While the study performed well, we also encountered some limitations. One of them is the missing feet in the real mirror due to its high sensitivity to tilt, as it amplifies misalignment in the mirrored world, revealing Z-fighting artifacts. We also had occasional hole-filling artifacts from hardware depth map pre-processing, revealing the real world to bleed through. Well, to conclude, there is no single winner. Soft is preferred for comfort, but dithering offers a stable compromise that boosts presence without the ghosting of alpha blending. Therefore, we can say that gradient-based methods are preferable, but with individual preferences deciding the type. So as a take-home message, we can say that we need to prioritize gradient-based rendering to improve pass-through embodiment, but, given the need for high individual variance, provide an option to toggle between soft and dithering modes.